All right, so in our last explainer, we cover the basics of the i3X data model. Today, we're going to get our hands dirty and dive deep under the hood to see how those relationships actually work. Let's get into it.
So you'll probably remember this address space for Pump 101. We saw it had all these different kinds of connections to other objects in the system.
We know there are three kinds of relationships, but how are they actually defined? How do they change the way we write our queries? And probably the most important question, how do they control the data that we get back? Let's find out.
Okay, first things first. In i3X, every single relationship type is a first-class object in the API. This means we can discover them and work with them just like any other object. And we do that with a really simple GET request to the /relationship-types endpoint. This one call gives you the complete dictionary of every possible connection type that the system knows about. Now, what's really clever here is the structure of the response. Each relationship has its own element ID, of course, but check out that reverse of field. This is so helpful. Has children's reverse is defined as has parent, and has components reverse is component of. You literally never have to guess the inverse. The system just tells you both directions automatically.
All right, this brings us to the core distinction you really need to understand, the difference between organizing your structure and composing your data. Take a look here. On the left, in blue, you've got an organizational tree. The plant, the building, the line, they're all linked up by the has-children relationship. This is all about structure. Then, on the right, in green, we have Pump 101's internal parts, the motor, the bearing, the sensor, and these are linked by has component. This is all about data composition. So, here's the absolute key takeaway. It is the parent object's is composition flag that dictates the relationship type to its children. Because Pump 101 is set to is composition true, its children become components. If that flag were false, they'd just be linked via has children instead. This is a property of the parent, not the child. Super important to remember that.
Okay, now for the payoff. Let's see how we can use these different relationship types to get exactly the data we need.
The main endpoint for this is post/objects/related. Think of this as your universal tool for navigating the entire data graph. And this just illustrates the power of filtering perfectly. If we query line 1 and ask for has children, we get back its pumps and conveyors. But if we query that very same pump for has component, we get its internal parts. It's the same endpoint, but a different filter gives you a completely different result.
And it's not just for hierarchy. We can ask for any relationship type we want. For instance, querying Pump 101 for the maintained by relationship gives us the technician assigned to it. This is how you can build these really rich, non-hierarchical graphs. This is where that distinction becomes absolutely critical. When you query for values, you can use a parameter called max depth. And here's the rule. Max depth only follows has component edges. It completely ignores those organizational has-children relationships. Let's see this in action. A query with max depth set to 1 just returns the pump's direct value. Simple enough. But if we set max depth to 0 for full recursion, it follows all those green has component edges and gathers up all the nested values. Now, what happens if you try that same query on the plant with its blue organizational edges? Nothing. Recursion only follows compositional relationships. And here is the beautiful result. Because we set up our compositional relationships correctly, a single API call using max depth 0 gives us this clean, nested JSON object with all the values for the motor, the bearing, and the temperature sensor all at once. So to wrap it all up, you use organizational relationships for structure, compositional ones for data aggregation, and non-hierarchical ones for everything else. It's 3 fundamental relationship types, all navigated with one consistent query pattern. Now, this is great for querying, but what if we want this data pushed to us the moment it changes? Well, that brings us right to our next topic, subscriptions and real-time streaming. We'll see you in the next explainer.